it's on to Art and Paul.
Yep, so we're going to talk about Bossberg Pump Station, and thank you for giving us the time. For many years, prior to me, and I know I've been talking about it in my time here, the deficiencies at our Vosburg Pump Station. Vosburg Pump Station is our largest pump station, both physically and by flow, heads and tails of anything else that we have. It is, I know Paul, you're going to touch on some of this, it's well over 40 years old. We're in dire straits with that station. Paul's going to touch on that. I know Patty, you've been there with us during last year's rains.
I was there.
Where we had 8 to 10 feet of raw sewage within the building because we have deficiencies. So early in 2021, we made a presentation. I made a presentation to the board to obtain a engineer review on the station. We sent out a quality-based RFP. MRB, Paul Chatfield, and his team were chosen. So in August of 21, for the last 9 months, his team has been working with myself and my team to create a rather comprehensive evaluation of the station. And I now will turn it over to Paul Chatfield to summarize what's in these 300 some odd pages that you put together for us.
All right, I didn't get paid by the page. All right. Okay. Well, thank you for having me here tonight to talk about the pump station at Vosburg. I was thinking on my ride here, how could I make it exciting to talk about pump stations and treatment plants? I've done this for 40 years, and I still haven't come up with a way to make it exciting. So I'll do my best. This is the Vosburg pump station, 601 Vosburg Road. This pump station provides sewage pumping through 2 force mains that discharge over by Whiting Road. And that pump station provides sewer service to kind of the northwest portion of Webster and a portion of Penfield. And I will tell you from the investigations, and I've been out there numerous times working with Art and the sewer department, the job that they do is really remarkable. To have such good staff all across the board. This pump station is in need of repairs, not because of the staff that you have working on it. It's 42 years old, and a 42-year-old pump station would be like having a 15-year-old car. You can keep it going. It's rusting out, you know, you might have to replace the brakes, and sooner or later you have to replace the motor. The pump station is the same thing. It has a useful life. It's well in excess of its useful life. I guess that's the first thing that I want to share. 2 things that we found relating to the system. First is the age of the system, and then the second thing is the significant component failures within the system. The pumps, the valves, the controls, many other things. But the operation and maintenance problems that plague the station, and nobody likes to have to pay for sewage, but they sure don't want to have it backing up into their houses. And you know, this is a problem that we got to make sure that we take care of. The capital improvement plan provides a comprehensive evaluation of the needs of the system, kept coming up with a plan of attack, a long-range plan of attack. One of the problems is that the existing pump station has no working flow meter. So as part of our investigation, we did 8 weeks of flow monitoring. Fortunate enough, we were able to pick up normal storms or normal daily events. Plus, we were also to pick up several storm events. Minimum flow in the middle of the night, a little over 330 gallons a minute. Normal daily flow, a little bit under 600 gallons a minute. That's your typical average across the board flow. The maximum average flow typically occurring at times when people are starting to use the bathrooms and the water usage at home. Early in the morning, later in the afternoon, and the evening. That was just a little bit under 1,000 gallons a minute. The pump station is designed for 2,310 gallons per minute. There are 3 pumps in the pump station. But we've had wet weather events that have gone well above 1,000 gallons a minute, and in some cases above 2,000, and in some cases above the actual capacity of the pump station, 3,000 gallons per minute and above. One of those events occurred, I think it was the 26th of October, and I think Patty, you had been out there.
I was there.
11 o'clock at night.
Yep. Just for reference, I looked at that pump station earlier in the day. I went out and visited the station early in the day, about 11 o'clock in the morning. It was after it had rained early in the morning. The pumps were keeping up with it at 11 o'clock in the morning, 11 o'clock at night, a whole different story.
There was pretty tense moments when it seemed as though it was taking care of it, and then it would kick off, and then it would start rising again, and how far is it going to rise? And our crews worked really hard on that all night.
And it was due to the antiquated controls we had.
Yep. So some of the concerns, certainly the useful life has been exceeded, but more importantly, one pump is unable to be serviced because the valves on the suction and discharge side of the pumps are deteriorated to the point where they're not able to keep the pump station closed, to be able to go in and operate. One pump is down entirely right now. That's a significant problem. So we're now, depending upon 2 of the 3 pumps within the system. I'm just going to show you some pictures. This is a couple of pictures. The south pump, which is out of service due to valve failure. This just shows the deterioration. Yes.
Are those, at that pump station, are all 3 pumps designed to be running at the same time, or is one generally for backup?
Okay.
Yeah, go ahead.
So normally, the pump station with 3 pumps, lead, lag, and standby. Right now, and actually, it's been for quite a while, we have a lead and lag.
Okay.
We do not have a standby. During high flows, you'll have 2 pumps kick on, and if needed, 3. Obviously, if you're getting to 3, we're in trouble. If you're getting to 2, quite honestly, in my opinion, you've got some high flows.
Right.
So.
Well, clearly, we need that third one running.
Yes.
This is a pretty
Oh,
significant problem.
absolutely.
It's crucial.
Yeah, absolutely.
I'm sorry for interrupting.
No, that's okay.
It's great.
This is just a picture of the raw sewage leaking on the floor in the pump station as a result of the damage to the pump and the seals. As I said, we're unable to isolate the pump for repairs. This picture, I don't know if you can see it there, but you can actually see the sewage and the water leaking down from the seal. I'm going to skip through this pretty quick. I've got a bunch of pictures I want to show you.
If you can go back a slide.
Sure.
So, in the event that we need to turn that pump on, there's no seals in it. So, what the staff is left with and is turning the pump on in raw sewage spraying across the roof. That's the environment they're working in. And that's the environment that they tried to repair this in and just couldn't get it and finally had to give up.
Other problems besides the pumps and the controls, the ventilation system within the wet well, and I'm going to show you some pictures of that. It's a corrosive atmosphere. Wastewater, as it comes into the wet well, and when it goes into manholes, the separation of the wastewater from the hydrogen sulfide creates that corrosive atmosphere, and the ventilation system in the wet well is inappropriate and inoperable. And top of that, the wet well capacity is very small. I'll show you the picture of that. The emergency bypass pumping system that is in place was designed and put into place in 1980 and does not sufficiently provide capacity in the event of a high flow condition where we have 2,300 gallons a minute operating or above that. So that system is in need of significant improvement. Big problem. Force main discharges into a manhole with a significant amount of deterioration from the hydrogen sulfide. The only way to repair that is to just eliminate it and replace it. I'll show you the pictures of that. And then some air release valves in the system that are inoperable, and some of them are rotted off. Here's some pictures of the wet well. And so the wastewater flow comes in at the top of the page, comes in, goes through the wet well. And the wet well is kind of the tank that provides a little bit of buffer so that the flow comes in and then it gets distributed to the 3 pumps. And in that, it's a very small well. Has a capacity of about 9,000 gallons, which is about 10 minutes at the very most of capacity. Not very much capacity at all. This is a picture of the ventilation system that, if we could really zoom in on that, shows some very deteriorated and rotted ductwork and equipment.
Paul, you can stay there for a second. So if you'll notice the yellow overhead crane, the yellow crane, the crane is rotted to the point it is inoperable. When our folks, our staff, has to, there's a grinder down below and a mixer, which we pull on a regular basis.
Can you point to the crane? I can't really see it.
Yep, it's right there.
Okay.
Right, so they have to actually get ladders out over by the door, hook up a chain fall up on a 10-foot ladder, hook a chain fall, try to get this equipment out, and then tear it all down. It's not the safest working environment.
I don't say that.
And that's done on a regular basis.
That's just unsafe.
Yeah. So here's a
And also
picture
the
of
blocking. The blocks on that wall seem to be separated too.
You
Yeah.
saw that on the left?
Yes.
Yeah.
Right here. Yeah. That's it. So we put an allowance in the budget for improvements to the structure of the wet well itself. Picture of a couple of the pumps. So there's 3 pumps. We just didn't get a picture of all 3 of them, but they're centrifugal pumps with a motor on top of it. And the next picture will show the valves. So this is a typical valve, and this is the pipe coming in from the wet well. The wet well is over here. Sewage comes in. This valve is a gate valve that normally is open. If you're going to operate and do a repair to the pump, you would close this valve, and this is the type of valve that is inoperable in the south pump. This happens so the flow comes in, goes through the pumps right here, and then comes out, and there's a check valve. And the problem with check valves is they get rags, get caught up in there, and they don't close properly, they don't operate properly. So you've got to get in there periodically. You see on top of the check valve is a flange that gets taken off when the shut down the suction and discharge side, take off that top, clean it, and repair it, get it back in service. And we're just unable to really be able to do that on a routine, regular basis.
Paul, if you can stay there for a second. So if you look at the check valves and see the staining, all the check valves are leaking. We, when I first started, we looked at rebuilding the check valves. The check valves are obsolete. We're not making rebuild kits for them. So, like Paul said, the inability to isolate the check valve, we have no way of cleaning any rags out. And also, Paul, if you can point to the stain below the suction line on the wall. Yeah. So there's a stain underneath each and every one of these 3 suction lines. That is the wet well leaking through. At one point, we had the wall injected to try to stop the seepage. The pipes are deteriorating, I'm sure Paul will talk about that, but that's leaking through that wall.
Yeah, so as part of the overall plan to rebuild the station would be take all that piping out, take the pumps out, replace them, but also on the suction side, that's an 8-inch diameter pipe, and what we, based upon our evaluation, have determined that it should really be a 12-inch pipe. And so the nice thing about putting a 12-inch pipe in there is then we can go in and do that repair so that we can cut out and core out a 12-inch pipe and put a new 12-inch pipe in there with a link seal and take away that problem that are identified with the leak. So it's a kind of a catch-22. You do it and you've solved really two problems. Okay. Generator, the life has been exceeded. The key with that is, as I mentioned, the wet well capacity is about 10 minutes. So in the event of a long extended power failure, we've got to be able to get that pump station back up and running right away. It's 42 years old. The normal life, in that 15 to 19 year time frame from what we understand from the industry. The controls are antiquated. Many of them are 42 years old. Technology has changed so much over the years that this is a case of needing improved efficiency and equipment that's available, because there's parts that are kind of robbing Peter to pay Paul.
So if you can, on the right-hand control, they're right there. So you can see there's a sheet of paper up there with masking tape. Those are notes my guys have to leave to what not to turn on, what to leave on, so the station runs. With new controls, as we're going to look at for all stations, we integrate basically a cloud system, so we can see at the plant what's going on. What's going on if we have a fault or anything like that. Right now, we have an individual that visits each station every day to check, and we will continue to do that. But to have real-time data on what the pumps are doing, what the flows are doing, it's just invaluable.
Here's probably one of the biggest concerns that I noticed when I walked in and took a look at, and this is from close to the original construction. These were chemical lines that were welded into the 16-inch ductile iron force main. Now the key concern with that is that's the force main. The flow of sewage is going from the pumps out of the station at 100 psi or something like that. If the welds on that green lines break, and sooner or later they will, that means that raw sewage is going to be shooting out of that line that gets broken, and it's really just a matter of time before that becomes a catastrophic problem. I'm not trying to be doom and gloom here, but that is one area, big area of concern.
Well, and then to your point, Paul, so those are what we're estimating, the thickness of those pipes that rotted close to 40 to 50%. 2 years ago, I had the guys go out and clean them and start spraying them every month with galvanized spray to try to slow it down. And we did that for 4 to 5 months to try to maintain it, as Paul said. When they fail, there's no stopping.
Yep. So here's a picture of the air release valves. So there's 2 air release valves, one on Vosburg Road and one on Van Alstyne at Shoemaker, right at the intersection. And this happens to be one that is got the air release valve installed still. We're not quite sure if it works or not. We don't think so. But you can see that the force main right next to it has a saddle with a cap on it, and that one has been broken off and a cap was installed. So both air release stations are in significant need of improvement, and they were put in for a reason, and they need to be put back into service and operation. So as part of the improvements, we would recommend making improvements to that. Here's the picture of the discharge manhole. You can see, if you look around the kind of the perimeter of it, you can see this is 2 force mains that discharge into this, this manhole. You can see the flow is coming through the northern force main. And what's happening is it's dropping down and it's swirling, and all the hydrogen sulfide is coming up and causing the corrosion and contamination and problem to the manhole.
Well, can you tell us what a force main is?
Oh, sure. Yep. So the force main is, so we have the pump station, and then there's a pipe that discharges the wastewater flow, and it's called a force main. And they call it a force main because it's under force or under pressure. So it's going, you know, from the pump station, you know, it's down low, and then it pumps up to the top of Vosburg Road, and it's pumping up in elevation until it gets to a point where it can then flow by gravity.
And there are no tie-ins to force mains or anything like that. I know that's been discussed, not to get off track or take it down a rabbit hole, but some people talk about, well, there's a main in front of our house. Well, if it's a force main, there's no tapping into it. It is a dedicated line to the discharge manhole. This specific pump station has 2 force mains due to the volume.
So my recommendations, based upon our extensive investigation, is that a comprehensive rehab of the facility is necessary. We believe that bypassing the entire pump station during construction will lead to the shortest construction time and will be the most cost effective. As part of that, the station would be bypassed. There'd be some improvements that were necessary to accommodate the flow for normal flows and also for that wet weather flow on the bypass system as part of the improvements. Improvements to the structure of the wet well and the ventilation system as I've shown. Replacement of the 3 pumps, piping, valves, etc. inside the station. We recommend switching to a dry pit submersible pump station configuration, which is the sewer department is familiar with it. We feel it's more reliable. The nice thing about taking the station down all at one time is that you've got a clean slate to work with inside that station there to reconfigure the pumps and reconfigure the valves and the piping in a manner that's best suited for the pump station. A new flow meter, put a flow meter in there to know what the flow of the system is. Replace the antiquated controls, replace the generator, install the bypass piping, as I mentioned, as part of that temporary bypass, which will become a permanent bypass in the future. Improvements to the air release valves, 2 locations, replacement of that force main discharge manhole, and improved security measures at the pump station itself. So this project will require multiple prime contracts because of Wick's law. Prevailing wage rates are required. So we came up with a estimated cost of $2.338 million for construction. We put a couple of contingencies in there, importantly because of the economy, the way that bidding is and the supply chain problems are. We've put a 15% contingency, plus we put a 10% material cost adjustment. We feel it's prudent for the board to consider both of those contingencies in establishing the budget. And then we've lumped together the legal, administration, and engineering services at, estimated at 25%. So the total project cost, $3,508,000, is the cost that we anticipate if we were to proceed ahead with design of the project later this summer and bid it in the fall and start construction in 2023. The cost of delaying, you know, who knows what the inflation rate is going to be, but I used a conservative 6% inflation rate. I think CPI is going to be around 7% possibly this year. So, you know, by putting the project off, 4 years, a $3.5 million project would go to $4.4 million, probably at a minimum. I'd like to, project schedule. So project schedule, we think anywhere from 21 months to 32-month time frame. We know that the board needs some time to digest this and work with the other Paul, with the money, and money Paul, and then start the process. 6 to 9 months for the design and the permits and approvals, a couple extra months for that. Typically on these projects, the shortest time period is the construction itself. And, we think that, we can have the station shut down for 4 months, but total construction probably in the 6 to 9 month time frame. So there's some risks with waiting. Potential for catastrophic failure, as we've talked about. Currently operating the station without full capacity. The chemical feed line, as I've shown, will flood the station with no ability to stop a leak. There's increased operational costs without doing anything. We can replace a pump or a motor if we could get in there and shut it down, but ultimately it's not in the long-term best interest of the town and the sewer department to do a Band-Aid approach to it. And increased future capital costs associated with waiting on the project. The corrosive atmosphere, is an unsafe working environment, and all components are well beyond their useful life. Certainly, these improvements are not considered optional, they're really inevitable and necessary. Okay, I'd like to open it up to questions or maybe final comments from Art.
Yeah, I actually got a question. So, Paul, once this project is all done, what is the lifespan of that pump station?
Well, I think you would be able to get another 40 years out of it. I think you would be able to. I mean, we're going to be making some structural improvements that need to be made to it. And I would full expect that the pump station itself would. I think there are times that a treatment plant itself would not. Now, within that 40 years, you're going to have to be replacing some pumps and some motors and things of that nature. But the structure itself and the system itself, 40 years. But certainly short-lived assets, things that need to be replaced periodically.
Yeah, Paul, you mentioned, if we wait, we might have to replace a pump or a motor. Bear in mind, we don't have the ability to replace a pump. The south pump we cannot touch at all. Either the north or middle pump fail. We're down to one pump. The station cannot run on one pump. So
it's a pretty comprehensive presentation. I appreciate it. The 10% material cost adjustment. I know where I work, we're seeing a 20% increase. And do you think that number should be a little higher than 10%?
It's hard to say.
Yeah.
I mean, I've seen some materials that have gone up 5%. I've seen some materials that have gone up 50%. It really, in some materials you can't get, or the delay on it is so long. So,
well, I agree 100% with your assessment regarding not waiting. I think the pictures tell a pretty drastic story here, and it's too bad that we had to wait this long. We have one pump that's inoperable, and we're just setting ourselves up for a catastrophic event. Yeah, I think we really need to seriously consider doing this sooner or later. Thank you for your presentation.
Sure.
This pump station actually has smaller pump stations feeding into it, correct?
Correct.
It's like a booster pump station.
Correct. There's a couple of stations at Discharge Manhole.
So yeah, there's a good portion of town. And Penfield.
It's a big.
Well, it was put in place when in 1980, and
1980.
we've seen significant growth in Webster since 1980.
And Penfield.
And great point, Charlie.
Yeah, and Paul, I think that you toured money, Paul. I think you toured this with us a while ago as well, didn't you? Did we go down and see this pump station?
Yeah, I was with you.
Yeah, and that
That
was
was
when it
We
was
saw firsthand.
running okay, and it still was not a pretty sight.
No.
So that night in October gave me a real good indication of just how subject to failure this pump station is. I just want to say that this is my third meeting this week on all things sewer. Yesterday's was a review of belt presses where we were watching sludge moving through there. I am the liaison to sewer, lucky me, but it's certainly been a great learning experience, and you know, this presentation we had me in love.
Follow that up. Jenny?
Well, like I said, we should, try to get this project as soon as possible or, get more, shouldn't do anything else.
The other thing that concerns me a great deal is that we're putting our employees in an environment that is completely unsafe, and we should not be doing that.
So, can I do my best impersonation of my friend, Councilman Abbott, and his extension? I hope it makes him proud when I wish him about this. So, Art,
Absolutely.
let's talk about how we're gonna pay.
Paul?
So,
I don't go anywhere without Paul.
That's good, and
I'm not a
so
finance guy.
let me lay the question out. I mean, and everything everybody said, and I mean, the thing is, Paul, I love, Paul Chatfield. I love the 15-year-old car example. That really resonates, like, what are we doing here, So, here we are, another $3 million plus project. The hits just keep coming, right? But we're getting pretty good the last couple of years of figuring out ways to apply for grants. The first thing today, we went from $2.5 million to maybe $3 million, the ARPA money. So there's a lot of different ways to pay that $3.5 million. Have you guys thought about that, Art? Have you talked to Paul? Paul Adams?
I have not. So Paul Chatfield and I have just finished this up in the last week or so, as far as the whole presentation and so forth. We've not talked to Paul Adams to this point.
I'm wondering if there are available grants for energy efficiencies on something like this.
Possibly.
And would be new pumps, would be, like, grab something out of it.
Might get a little bit.
Yeah. I know, Penny, you had sent over something with FEMA
Generators.
on generators. That's a very large generator that needs to be replaced. And we need to get longer runtime out of it. Right now, it has a very, very short runtime. So that can be an opportunity for us. If FEMA will, that's something that we
Is such a project to build eligible for a WIA grant, or is that only the treatment plants?
I think it's only available for treatment plants.
I had to research that. I was almost going to think that it would be.
Okay.
But at any rate, whatever you decide as far as grants go, the WIA grants, I don't think have been announced at this point. We're in the process of working in our office. We have grant writers working on the project, so that's something that they could look at. But I would say if you're going to first thing, try and get your arms around figuring out how you're going to either finance it or how you're going to approach the grants. But because that design process and the approval process will take 9 months to 12 months, my opinion would be proceed with the design of the improvements, knowing that one way or another you're going to get the funds. Either you're going to get it through grants or you're going to figure out how to make it happen from your standpoint. That way that you're progressing ahead. And the other thing is it's showing somewhat of a goodwill that you have skin in the game, that you are starting the process of design so that you can be ready to go, and I don't know if you would call that a shovel-ready, but that's getting pretty close to being a shovel-ready. If you have plans put together and you have permits and approvals, and you're ready to go.
Right, and I think you're absolutely right, Paul. We run into this, we did the same process with our phase one at the treatment plant, and also with our current project. We needed to be shovel ready. I believe that we had grants were going to be announced literally any day. I got an email today. We're still waiting. I mean, they're a few months behind, but we're hoping to get those. Would you be able to talk to your grant team to see if something like this would be available for a big grant? Sure. Or any other funding?
Sure.
Hard to believe that pump station will last another 2 years.
I didn't do a good job as council. He's gonna give me probably a C.
Well, I mean, that's all you did.
You think you'd give me a D? Give me.
Just ask the councilman, have your questions been answered?
Yeah, mine had been.
So the design phase, what steps does the board need to take to move in that direction?
We would need to get a proposal from MRB for design fees and scope, look at them on scope, and then or at that point, it really would follow the same as we've done with the plan and so forth.
So Charlie, do we need a resolution to move ahead with having put the scope for design together?
No.
No.
No. That's something that we could work on.
Yeah.
Well, I would, not speaking for anyone other than myself, but I'm certainly in favor of moving forward in that direction.
And I think, not speaking for the board, but that would be the logical next step to work on a scope, obtain a cost for design, and then bring it back. Yeah, exactly, for further discussion.
And it's also, from what I've seen in history, it's also good to start doing those scopes with this information that's fresh and pertinent, as opposed to, well, we really can't do it this year, let's kick it down the road, and then all of a sudden, we need to do all this study work again.
Right.
So I think we've got, a good basis for what we need to start with.
Great point.
Yeah, I'll work with Art in developing the scope and putting a draft proposal together, and then present it to the board for approval.
I don't know who had mentioned this, the supervisor had mentioned it, okay, we got another pump station. I will say, due to the help of our budget, all, we've been able to, a lot of our smaller pump stations, we've absorbed those upgrades and modernizations into our budget. This year we have Shoecraft pump station, which will receive new pumps, a new control panel. Actually, the guys started working on some of that this week. Our HAPA pump station, which is right outside of a senior living facility, a very problem pump station. We spent a lot of time there cleaning bags and diapers and things of the sort. We were able to purchase 2 new pumps for $10,000. We have the ability in-house to go ahead and change those. So that's going to happen this year. And we've changed pumps and upgraded pumps throughout the town, and we'll continue to do that. We're finding problem areas, older pumps, creating efficiencies, reducing overtime, and reducing call-ups. It's allowing us the time to go ahead and do the maintenance that's been really deferred for many, many years. And to your point, Paul, that staff in years past was so adept at really just keeping things running. And that's what you're seeing there. And we're seeing it all over town, is keeping things running. We're very good at it, the plant, keeping things running. But once you start peeling back the onion, it's like, this stuff is 20, 30 years old. We're throwing good money after bad at it, and just in parts, and let alone the paper at the time. So it's a great staff. They work hard, they know what they're doing, but they're seeing the value of, okay, we need to upgrade. It's not as hard on them, it's not as hard on the system.
Oh, I've said it before, Mark, I'm going to say it again, we're very fortunate to have you bring these issues to the forefront because, as we saw tonight, a lot of these things should have been addressed years ago, and we're just thankful that you're here to educate us.
Well,
Thank you for your presentation, Ron.
Thank you, John. I think it's really, the thanks goes to the leadership of the town to be open to listening to these presentations. That's really where it comes from. Giving us the ability to, as you know, to trust in the department heads and say, okay, yes, go ahead and work with MRB to get that PER, and then bring us back in 9 months later to listen to the findings.
Thank you.
There's nothing fun about wastewater treatment and wastewater conveyance, but it's necessary. It's not a park, it's not a nice community building or something like that, but we all want and expect flush our toilets and have them work. And turn the water on, have the water work. Those are our expectations. So it's the people behind the scenes that make it happen. You know, it's the operators and the staff and all that stuff. So hats off to the board for taking 50 minutes to listen to me ramble on about pumps and pump stations.
Well, I appreciate your very thorough study. Thank you.